Namaste and a very good morning, dear students. The chapter that we are going to start today is Human Eye and the Colourful World. You have already studied in the previous chapter about refraction of light by lenses, concave and convex. You know that concave lens is a diverging lens and a convex lens is a converging lens. How is this information useful to us in studying the human eye? We are going to find out, and by the end of our discussion today, children, you will be able to identify various parts of the internal structure of the human eye, understand and explain the function of each and every part of the human eye. We will talk about myopia and hypermetropia, which are the defects of vision. We will also talk about presbyopia. You will be able to apply the knowledge about lenses to understand the defects of vision and analyze the usage of corrective lenses. So, children, you all know that human eye is the most valuable and a sensitive sense organ. It enables us to see the wonderful world and the colors around us. Do you know that it is actually like a camera where the image is formed by the lens on a screen? But in this case, the screen is called the retina. This image formed is real and inverted. Then how do we see the objects as they are? This mystery we are going to solve during our discussion, but let us first identify and observe the various parts of the eye. We are just going to identify, right? So, you can see in the model, the front part of the eye is known as the cornea. It is just a membrane from which light enters. Just behind the cornea is the iris. You can see it is a muscular circular diaphragm. And if you can see the small opening in the iris, this is called pupil. Just behind this iris and pupil, you will find an eye lens. This is convex in nature, but the eye lens which I have in my hand is made up of glass. That eye lens is fibrous and is made up of jelly-like material. It is held by some muscles, and those muscles are called the ciliary muscles. The image is formed on a screen, and that screen is called the retina. The inside portion is the retina. The eyeball is also, if you can see, it is spherical in shape, and the diameter of this eyeball is about 2.3 centimeters. Since you have seen it in 3 dimensions, let us now understand the function of each part and how will you make the diagram of human eye. As you can see, the outward bulge called the cornea and the eye lens which is convex in nature. Light enters the eye through a thin membrane, that is the cornea, which is a transparent bulge on the front surface of the eyeball. Most of the refraction for the light rays, that is bending of light when it enters another medium, occurs at the outer surface of the cornea. When the light rays fall on the eye lens, further refraction takes place. Now imagine that you enter a cinema hall. It's very difficult for you to see things inside that dark hall. But after a while, have you noticed that you can see the things absolutely clearly? You watch the movie, and after watching the movie, when you suddenly come out in open and it is daytime, in broad sunlight, you tend to close your eyes because the light entering your eyes is too much. Although after a while, you feel absolutely fine and you are adjusted to the outside environment. So, which part of the eye decides or regulates the amount of light which is entering your eyes? It is called the pupil. Remember that size of the pupil is controlled by iris. Notice that in darkness the black portion has become small and in bright light its size has increased. Now, in between the lens and the cornea, in fact just behind the cornea is the iris, which is a dark muscular diaphragm that controls the size of the pupil. Now, in bright light, the pupil becomes small, as I just told you, so that less light enters, and in darkness, the pupil becomes large, so that maximum light enters. Now, the eye lens forms an inverted real image of the object on the retina. Children, remember that retina is a delicate membrane. It has a number of light sensitive cells, and that is the reason we can't see in darkness. When light falls on retina, the light sensitive cells get activated and generate electrical signals. These signals are sent to the brain via optic nerves. Now, the brain interprets these signals, processes the information so that we can see the objects as they are. Isn't it amazing? This answers our first question, that the image formed on the retina is real and inverted, but we perceive the objects as they are because of the intelligence of our brain. Time for a recap, children. Light enters through cornea. Iris controls the size of pupil. Pupil regulates amount of light entering. Eye lens forms real inverted image on retina. Light sensitive cells on retina get activated. Electric signals are generated. Optic nerves sends signals to the brain. Brain interprets the signals and processes the information. Now, it's time to talk about one very important quality of the eye lens. I just told you, children, that eye lens is made up of fibrous jelly-like material. Its curvature or focal length can be changed to some extent with the help of ciliary muscles. But why should the curvature or the focal length of eye lens change? This is because, sometimes you have to see far off objects like stars, and on other occasions you might have to see things around you or just read some text from the book. The change in curvature of the eye lens actually changes its focal length. So, when the ciliary muscles are completely relaxed, the lens becomes thin and the focal length increases. This enables us to see distant objects clearly. And when you are trying to read a book, the ciliary muscles get tensed. This increases the curvature of the eye lens, and the eye lens then becomes thicker. Consequently, the focal length of the eye lens decreases, which enables us to see the nearby objects clearly. This ability of eye lens to adjust its focal length is called accommodation. Now, just try to read a printed page by holding it close to your eyes. You know what is going to happen? You are going to see blurred images, or you will feel strain in the eye. Remember when you were young, your parents and teachers told you to keep the book at a distance? To read comfortably and distinctly, you must hold the book or the reading material at about 25 centimeters from the eyes. The minimum distance at which objects can be seen most distinctly without any strain is called the least distance of distinct vision. It's also called the near point of the eye. For a young adult with normal vision, the near point is about 25 centimeters. Okay, tell me something. How far can we see? Stars, moon, that means we can see up to infinity. The farthest point up to which a normal eye can see clearly is called the far point of the eye, which is infinity for the normal eye. So, a normal eye can see objects clearly that are between 25 centimeter and infinity. Children, sometimes the lens of people at old age becomes milky and cloudy. This condition is called cataract. This causes partial or complete loss of vision, but the good news is that it is possible to restore vision through a cataract surgery. But tell me, haven't you noticed people wearing spectacles? Because sometimes they can't read properly or even see things which are far off. Why does this happen? Let's find out. When people cannot see road signages or the number plate on vehicles properly, or the far off objects seem blurry to them, that means they cannot see distant objects clearly. This defect is called nearsightedness or myopia. Now, a person with myopia can see the nearby objects clearly, but cannot see the distant objects distinctly. A person with this defect has the far point nearer than infinity, which means that such a person may see clearly up to a distance of few meters. In a myopic eye, the image of the distant object is formed in front of the retina and not at the retina itself. Please remember that this defect may arise due to excessive curvature of the eye lens or elongation of the eyeball. This defect is corrected easily by using a concave lens, which is a diverging lens of suitable power, as it will bring the image back onto the retina, and thus the defect is corrected. Summing it up, myopia, far point comes closer, image is formed in front of the retina, corrected by a concave lens. Okay children, at times we have noticed that your friends, family members, or many of you yourselves cannot read a newspaper or a book easily. This defect, in which a person has difficulty in seeing the nearby objects but can see far off objects clearly, is called far-sightedness or hypermetropia. Near point for the person is farther away from the normal near point, which is 25 centimeters. Now, such a person will have to keep the reading material much beyond 25 centimeter from the eye for comfortable reading. This is because the light rays from a close by object are focusing at a point behind the retina. This defect arises due to two reasons. The focal length of the eye lens is too long, or the eyeball has become too small. Well, the defect can be corrected by using a convex lens of appropriate power. So, in totality, hypermetropia or far-sightedness is a disorder in which the near point is beyond 25 centimeters. The image is formed behind the retina and it can be corrected by using a convex lens. Now, let us talk about a distinct disorder which occurs specifically in old age. You know children that power of accommodation of the eye usually decreases with aging, which means that the ciliary muscles weaken with age, so that so the focal length of the eye lens cannot be moderated. For most people, the near point gradually recedes away. Sometimes a person may suffer from both myopia and hypermetropia. This defect is called presbyopia. Such people often require bifocal lenses, which consists of both concave and convex lenses. So, the upper portion consists of a concave lens. It facilitates distant vision, and the lower part is the convex lens, which facilitates near vision. So, this brings us to the end of our discussion. You can now identify, understand and explain cornea, which is the front part of the eye covered by a membrane from where light enters, the dark circular muscular diaphragm called the iris. Opening of the iris is the pupil, eye lens which is convex, jelly-like and fibrous, ciliary muscles which help to change the focal length of the eye lens. This is called the power of accommodation of the eye. Retina, the screen on which real inverted image is formed. Near point of the eye is 25 centimeters. Far point of the eye is infinity. And now you can apply your knowledge about lenses to understand the defects of vision and of course the usage of corrective lenses. Myopia, nearsightedness. Image is formed in front of the retina, corrected by concave lens. Hypermetropia, farsightedness. Image is formed behind the retina, corrected by a convex lens. Presbyopia, caused by weakening of ciliary muscles, corrected by using bifocal lenses. So, practice drawing label diagrams for human eye and ray diagrams for myopia and hypermetropia, depicting the defect, reason and correction. Until next time, stay safe and keep practicing. Thank you.